Happy morning, my dear children. The last class we learned about that absorption, application, and physical and chemical absorption. Everything, am I right? Today we shall continue after the applications of catalysis. In 1836, one of the great scientists, Berzelius, certain substance can loosen the bond of the reacting molecule. Certain substance can loosen the bond of reacting substance. And also maybe it can be increase the rate of the reaction. By that substance, the reaction can be somewhat speed or slow. So he find out one name is called catalyst. What is that? Catalyst. So today our learning objectives to learn about catalyst. What is about the catalyst? The small class you maybe learned about the catalyst. The catalyst is a substance which alters the rate of the reaction, am I right? Without changing the chemical reaction. As per the catalyst, we have positive catalysis and also the negative catalysis. What is about the positive catalysis means? The rate of the reaction is increased by we are adding one substance. Whenever we are adding one substance to the reaction rate is increases. That we call as positive catalysis. A very good example is the decomposition of hydrogen peroxide by adding colloidal platinum. The hydrogen peroxide is converted into water and oxygen. Suppose we are adding colloidal platinum, the reaction is go somewhat fast. Such a type of the reaction is called as positive catalysis. And the negative catalysis means when we are adding one substance to a particular reaction, it will be slow the reaction, decrease the speed of the reaction. Increasing or decreasing. Increasing means positive, decreasing means negative. Okay. This is about the negative catalysis. Then it is again broadly classified into two types. One is about the homogeneous catalysis and about the heterogeneous catalysis. Homogeneous catalysis means here the reaction, catalyst and product. Clear? Reaction, catalyst and product are in same phase. Homo means same. Okay, don't forget. Same phase. Yes, read that. Homogeneous catalyst. Next about the heterogeneous catalysis means the reaction and the catalyst are different phase. That is called as what? Heterogeneous catalysis. The homogeneous and heterogeneous catalysis having a number of reactions. So we should be write all the reaction. For example, the first one reaction, sulfur dioxide is converted into sulfur trioxide. Okay. Sulfur dioxide for the homogeneous catalysis, sulfur dioxide SO2 reacts with oxygen in the presence of NO acts as a catalyst. And we get the product is SO3. Here SO2 gaseous phase, oxygen gaseous phase, NO gaseous phase, and also sulfur trioxide is also gaseous phase. So the reactant, catalyst, product on same phase is called as homogeneous catalysis. And here we have a number of reactions we can be discussed one by one. Anyhow, the heterogeneous catalysis means the reaction catalysts are in different phase. Okay, that we are learning already. We learned that on Habe's process, contact process. Habe's process means the manufacture of ammonia by the reaction between nitrogen, hydrogen in the presence of iron as a catalyst. And about the contact process, sulfur dioxide plus oxygen, we get sulfur dioxide in the presence of platinum and also vanadium pentoxide act as a catalyst. Okay, a lot of equation we have. Please, we can be write all the reaction one by one. Okay, please all of you open the note. We can be write all the reaction. Please. To learn about catalysis. In 1836, Berzelius, one of the great scientists, Berzelius, identified certain substance loosen the bond in the reacting molecule. One of the reacting molecule, certain substance can the ability to loosen the bond in the reacting molecule, and also one more function, it can be increase the rate of the reaction. That particular substance can increase the rate of the substance, the rate of the reaction. Am I right? So, and also one more point, he also found that these substance did not undergo any chemical change. Okay, any chemical change. So that he gave the name as catalyst. What? Catalyst. Okay. In 1836, one of the great scientists, Berzelius, identified certain substance loosen the bond in the reacting molecule. One of the reacting molecule, for example, it can be taken as A plus B. This is one of the reaction. A plus B gives AB. For example, I am saying one of the example. Whenever we are adding certain substance, here this substance can loosen the bond in the reacting molecule and also increase the rate of the reaction. The particular substance did not undergo any change chemically or any change in chemical reaction. So he gave that substance name is called as what? Catalyst. Anyhow, we should be say the definition for catalyst. Here, there are many substances which retard the speed of the reaction. So what is the definition for catalyst? What is the definition for catalyst? The catalyst is a substance which alter, don't forget that, which alter the rate of the chemical reaction without itself undergoing chemical change. Okay, what's the definition? One of the substance, a substance which alter the rate of chemical reaction without itself undergoing chemical change. Okay, this phenomenon which involves the action of the catalyst is called catalysis. Okay, anyhow, whenever we are learning about the catalyst can be classified into many types. Okay, first of all, we can be learn about the positive catalyst and negative catalyst. positive catalyst and negative catalyst. And negative. Here, positive catalyst. What do you understand about the positive catalyst? Whenever we are adding one substance, the rate of the reaction is increased by the presence of catalyst. Okay? The positive catalyst, the rate of the reaction is increased. The rate of the reaction is increased in the presence of catalyst. We are saying that positive catalyst. So, what is the examples of positive catalyst? How can it be done? An example. The decomposition of hydrogen peroxide. Decomposition of hydrogen peroxide. Okay. So, the formula for hydrogen peroxide is H2O2. This H2O2 undergoes the decomposition. We get water, H2O plus oxygen. You have to balance the equation. 2 oxygen. So make it 2 here. Now the equation is balanced. Okay. Anyhow, here which catalyst we are using means colloidal platinum. Colloidal platinum. Colloidal platinum. Here. So here when we are adding one substance, here the reaction is increased by the presence of colloidal platinum. Here. And also, one more example we can be say potassium chloride. The formula for potassium chloride is KClO3. Potassium chloride. This undergoes also decomposition. We get KCl, potassium chloride, and also oxygen. We have to balance the equation here. So here having 3 oxygen, 2 oxygen, make it 2 here, 2 here. Here also 3 here. Here, the potassium chloride is converted into potassium chloride and oxygen. Okay, clear? But whenever we are adding one of the catalysts is MnO2, manganese dioxide. Okay, so now the speed of the reaction is increased. When we are adding one of the catalysts, the speed, the reaction is going fast, somewhat fast. We get potassium chloride and oxygen. This is about the examples of positive catalyst. I think that your textbook not having sometimes the example. So try to write this example. Okay. And about the negative catalyst we can be discussed later. Anyhow, what is the definition for negative catalyst? It will be slow. That means the rate of the reaction is decreases in the presence of catalyst. The rate of the reaction is decreases. When we are adding one substance, by means of that substance, the rate of the reaction is increases. So decreases. Decreases means negative and increases means positive. The rate of the reaction is increases means positive. The rate of the reaction is decreases means negative catalyst. Again, the two main catalysts are homogeneous catalyst and also the heterogeneous catalyst. Okay, there are two main types of catalysis. One is about the homogeneous and another one is about the heterogeneous catalyst. First one is a homogeneous. Homogeneous catalysis. Here, the reactant, catalyst and also the product are in same phase. Okay? The reactant, product and catalyst are present in the same phase. Such a type of the reaction is called as homogeneous catalyst. We can be saying same phase. That means reactant, catalyst and product. Reactant, catalyst and product on same phase is called as homogeneous catalysis. For example, sulfur dioxide, the reaction between sulfur dioxide and oxygen, the presence of NO, we get SO2 and combines with O2 to form SO3 plus NO. Here, this SO2 and O2 are the reactant. NO is the catalyst. We get the product. Now, NO also, so from there, the product is okay. Anyhow, here we have to balance the equation. Already I told you about the balanced two equation. You can be making 2 here, 2 here. Then oxygen, there, 2, 6. Okay, here sulfur dioxide is a gaseous phase. Okay, gaseous phase, gas. Oxygen also gas. NO also gas. SO3 also gas. Okay, gas phase. Okay, so everything is in gaseous phase. So the reactant, catalyst, product, of the same phase is called as homogeneous catalyst. Okay, and also as per our textbook we have a lot of examples. That all the examples you should learn because they will ask in the one word question. Okay, so you should learn all the other example for the 2 mark and 3 mark. The definition and also the example is enough. Any one example is enough. Those who are interested, you can learn about all the remaining questions. Anyhow, the next one, acetaldehyde. That is the formula for acetaldehyde is CH3CHO. The acetaldehyde, we are adding one of the catalyst is I2. So what is the product obtained? The CH3 on combines with the hydrogen. The CH3 on combines with the hydrogen, we get CH4. This carbon on combines with the oxygen to form carbon monoxide. And also I2 also leaving out, right? I2. Iode. Here, this is in vapor state. Okay, vapor. Here, reactant. This is the catalyst also, vapor. Product also vapor. Carbon monoxide also vapor state. Iron is a vapor. Everything are in vapor state. So can you say which reaction? Is it a homogeneous or heterogeneous? Heterogeneous means different. Is it homogeneous? Homogeneous catalyst. Next, another more example is hydrolysis of cane sugar. Okay, cane sugar. The formula we are saying the sucrose formula. That is C12 H22. O11 sucrose. Alright? This undergoes hydrolysis. That means we are adding water. Okay, that is water in the presence of the mineral acid. You can be say sulfuric acid. Okay, sulfuric acid. We are saying sulfuric acid. So what are the products are obtained? That means the hydrogen will be attached here, the oxygen will be attached here. So it is, we get 2 products named as C6H12O6 plus C6H12O6. Am I right? One is a glucose and other one is a fructose. Okay. Okay. We both having the same molecular formula. That is okay, but different the structure. Structure only different. Molecular formula same. That is we have seen the isomerism. Am I right? Compound having same molecular formula, but different in the structure. We have seen the isomerism. That also we have the lesson in biomolecules. We can discuss later. Okay, anyhow, we should be write the equation. The hydrolysis of cane sugar in the presence of mineral acid, we get glucose sugar, that is glucose and fructose. Okay? Here everything are in aqueous solution. Okay? Aqueous solution. Everything are in liquid, we can be say liquid state. Otherwise, we can be say aqueous solution. Liquid state. Okay. Next one is, next equation is about that ester on hydrolysis with acid or alkali as a catalyst. Okay. Ester. What is the formula for ester? CH3 COO C2H5. The name of the compound is C2H5 means ethyl. Am I right? Ethyl. CH3COO acetate. The name of the compound is ethyl acetate. Ethyl acetate. This ethyl acetate undergoes hydrolysis with water in the presence of an acid. Which acid? Mineral acid, that is called sulfuric acid. So what product is obtained? The hydrolysis is converted into H plus OH minus. Am I right? So what's the product? CH3COOH. CH3COOH. Am I right? CH3COOH plus C2H5OH. C2H5OH. What is that? This is called as an acetic acid. Acetic acid. This is called as an ethyl alcohol. Whenever you are learning, you should be, at least you should be learn about the common name. Otherwise, IUPAC's name. You cannot be mixed both the two names, okay? If you are writing, IUPAC's name is also okay. Otherwise, the common name. I think that the better line is, common name is very easy, okay? Anyhow, as per your choice. Here, ethyl acetate on react undergoes hydrolysis with mineral acid. We get acetic acid and ethyl alcohol. Okay, these are all in same phase, that is liquid state. Same phase. So, these are all what? Homogeneous catalyst. There is no any other solid state or any other vapor state like that. All the equations are in same phase. It may be a solid, or it may be a liquid, or it may be a gas, or it may be a vapor state. Anyhow, all same phase are called as homo means same. Okay, same phase. Clear? Next about that heterogeneous catalyst. Okay, here. What is about the heterogeneous catalyst? That means in reaction, the catalyst present in different phase. Okay, the catalyst present where? Different phase. For example, we can be saying preparation of sulfur trioxide. Okay, sulfur trioxide. That we are saying the conductive process. Okay, heterogeneous catalyst. Okay, here the reactant and the product, the reactant and the catalyst are different fields. For example, conductive process. Already we learned that what is about the conductive process. That is the manufacture of sulfur trioxide, the preparation of sulfur trioxide. Am I right? SO2 plus O2 in the presence of PT or V2O5, vanadium pentoxide. Okay, we get the product SO3 on reacts with oxygen, we get SO3. SO2 on react with oxygen, we get SO3. Sulfur trioxide. You have to balance the equation. Make it 2 here. Okay. Anyhow, this is a gaseous state. Gaseous state. PT and vanadium pentoxide both are in solid state. Otherwise, solid phase. Okay? Clear? So, sulfur dioxide on react with oxygen in the presence of platinum, otherwise called vanadium, not otherwise, platinum or vanadium pentoxide, we get SO3, sulfur trioxide. Gaseous state and also solid state. Okay, anyhow, the second one about that Habe's process. All of you know that on Habe's process means the manufacture of ammonia. Don't forget that. Previous lessons we learned that one. Manufacture of ammonia for Habe's process. And the sulfur trioxide is the conductive process. The reaction between nitrogen and plus hydrogen, we get ammonia, NH3. 2 nitrogen, 3 hydrogen. So, here we are using one of the catalysts is called Fe. Iron acts as a catalyst. And also one more promoter also having, that we can be discussed later. But what is a promoter means? Molybdenum, MO, molybdenum. That we can be discussed later. Okay, there you go. As per our textbook, that is only catalyst will be having. Nitrogen on reacts with hydrogen to form ammonia. Here nitrogen and hydrogen are the gaseous state. Fe is the solids. Okay. So this is an example. The reactant and the catalyst are in different phase. The reactant and the catalyst are in different phase. Here called as what? Heterogeneous catalyst. Okay. Then about we can learn another more example as per the textbook. I think that we have more than 6 examples. We should be learn all the examples. Okay. Those who are interested, you can be learn all the equation. Otherwise, please at least you should be learn 1 or 2 equation is enough. Okay. That is as per your choice. Anyhow, the next one is oxidation of ammonia. That is oxidation of ammonia. Nitrogen, that is ammonia, on reacts with oxygen, we get nitrogen combines with oxygen to form NO. Nitrogen combines with oxygen to form NO. Hydrogen combines with oxygen to form water. Okay, water. So how can you balance the equation? The easiest way, you should be taking return practice. Okay, we are using 4, 5 because many times I told you about how to balance the equation. 4 nitrogen. So oxygen how much? 5 2s are 10. Okay, so make it here. 6, 3. Hydrogen. 4 3s are 12. Okay, 12. Now the equation is balanced. Am I right? So 3 oxygen. 6 plus 4. 6. Here I have 6. Here I have 4. So make it here 5. Now balance. Oxygen is balanced. Okay, yeah. The next one is here. This is the gaseous state of ammonia Oxygen is also gaseous state. Here, which catalyst we are using is platinum, PT, platinum. Here, platinum is a solid state, solid phase. Okay. Here, the reactant and the catalyst are different. So, we are called as what? Heterogeneous catalyst. Which catalyst? Heterogeneous catalyst. Next one is about the hydrogenation. That is a hydrogenation of unsaturated organic compound. Unsaturated organic. The saturated organic compounds and also unsaturated organic compounds. Saturated means we can say that having a single bond. Here unsaturated means a double bond. Don't forget that double bond or triple bond. Okay. Here, so double bond, one of the double compound I am taking double bond compound I am taking that is CH2 double bond CH2. Ethylene. The name of the compound is ethylene. Ethylene on react with hydrogen. Ethylene on react with hydrogen in the presence of nickel act as a catalyst. Nickel act as a catalyst. So hydrogen is attaching here. One of the hydrogen attached here, CH2, is converted into CH3, and another more hydrogen also like that. CH2 is converted into CH3. So what is the product means? CH3 single bond CH3. So double bond is converted into single bond. This is an unsaturated organic compound. This is a saturated organic compound. Okay, here CH2 double bond CH2. We are taking another one, maybe a gaseous state. Here also gaseous state. Here solid state, nickel. Okay. Next one is about the decomposition of hydrogen peroxide. Decomposition of hydrogen peroxide by using a platinum. Okay, hydrogen peroxide has H2O2. This is we can be taken as a liquid state. Hydrogen peroxide reacts on decomposition the presence of platinum, colloidal platinum. Here, this is liquid phase, this is the solid phase. Okay, platinum. Previously, I told you that this is what? Solid state. Am I right? Anyhow, what is the product? Means water plus oxygen. Water plus oxygen. So, how to balance the equation? Make it 2 to 2. Here, liquid phase is different. Hetero means different. Homo means same. Homogeneous. Same phase. Heterogeneous, different phase. Okay, different phase is called what? Heterogeneous. Don't forget it. The last one equation. The reaction between benzene and acetyl chloride. Benzene and acetyl chloride. We get what is the catalyst we are here using the presence of anhydrous aluminum chloride. Anhydrous aluminum chloride acts as a catalyst. The product is acetophenone. Okay. What is the formula for benzene? Can you say? C6H6. The formula for benzene. So that compound having 6 carbon and 6 hydrogen. Am I right? So I am drawing like that. Okay, this is called not a benzene. We should be give the bond alternative double bond. Okay, suppose we are using double bond, next single bond, double bond, single bond, double bond. This we are called as what? Benzene. Otherwise, this also correct. Okay, this also correct. Anyhow, as per your choice, this also mentioned like that. Double bond, single bond, double bond, symbol like that. Okay, anyhow, this is about that what? Benzene. This benzene reacts with acetyl chloride. Acetyl chloride means what is the formula for acetic acid? CH3 COOH, acetic acid. In the presence of anhydrous aluminum chloride. Here we need not acetic acid, acetyl chloride. So replacement of OH by adding Cl. So the name of the compound is acetyl chloride. Acetyl chloride. Okay. In the presence of anhydrous AlCl3. Anhydrous AlCl3. So what is our respective product? Here this group will be attached to benzene. That means the acetyl chloride is attached to anywhere, whatever may be the place. Okay, that particular place, one of the hydrogen should be leaving out. For example, listen all of you. This area having carbon and hydrogen. Am I right? Here carbon and hydrogen. Here carbon and hydrogen. Here carbon, hydrogen, carbon, hydrogen, carbon, hydrogen. So the formula is C6H6. Okay, dear? So suppose I am adding this place. Here having carbon, hydrogen. Am I right? So this carbon, this hydrogen combines with Cl. So what's the product? HCl. What's the product? HCl. The remaining group will be attached here. So what is our respective product? That is what? This COCH3. This is called what? Acetophenone. Acetophenone. Clear? Can you write? Have it out from this area. So anyhow, about that, this also about that we can be saying it's a liquid state, this is the solid state. Okay, so we get an acetophenone. Okay, acetophenone. Anyhow, today assignment. One is positive catalyst. Positive catalyst. Example. With example, okay? Homogeneous catalyst. With example, any one example, okay? Here also any one example. Heterogeneous catalyst. With the example. Anyone, okay? So, what I am expecting here means, positive catalyst, you should be write the definition. A one line definition is enough. One line definition and any one example. I wrote two examples. Homogeneous catalyst. Write the correct appropriate definition and also one example. Next about the heterogeneous catalyst, same like that, the correct definition and one example. Okay. Total 2 mark question 3 I gave the assignment. Please all of you write the assignment. Okay. Thank you all for your time. Have a nice day.